2x plus 3. Nothing is there in denominator, so we don't have to worry. So we'll directly apply the limit. So I'll get 2 into 1 plus 3, that is 5. So let me find out f of 1. So f of 1 will be 2 into 1 plus 3, so that is also 5. So I am getting f of 1 is equals to limit of x tends to 1 f of x. So by second definition, my f of x is a continuous function. She told us to check if the function is continuous or not, and we have got that the function is continuous. Let's see one more. F of x is equals to x cubed plus 3 when my x is not equals to 0 and the value of f of x is 1 when x is equals to 0. So again we have to discuss or we have to check if the function is continuous at this point x is equals to 0 or not. So here there is nothing greater than 0 or less than 0. Either it is equal to 0 or not equal to 0. So again we will have to go by the second definition. So first we find out limit of x tends to 0 f of x. So that will be this. Limit of x tends to 0 x cubed plus 3. So that is going to give me the answer when I substitute the limit 0 plus 3, which is 3. And f of 0 when x is equal to 0, the value is given as 1. So we can see that my limit of x tends to 0, f of x is not equals to f of 0. Hence, okay, my function is discontinuous at x is equal to 0. So this is how we can apply the definition, okay, and find out if the given function is continuous or not. Why do we require it? Because only if the function is continuous, it is differentiable and integrable. That is, only if my function is continuous, I can take derivative of that function, I can take integration of that function. Now, why do we even want to take derivative or integration? Because if we try to understand the basic or the general definition of derivative is rate of change of one quantity with another, which means wherever two quantities are dependent on each other, change in one will always cause the change in other. So in the real life situations, each and everything is dependent on each other in some or the other way. Hence, directly or indirectly, change in one is going to cause change in other. And if we want to find out by how much amount the changes occurred, we use the maths called as derivatives. So we won't be applied to we won't be able to apply derivative if the function is not continuous. Hence, okay, we will always be in the pursuit of finding out if the function is continuous or not. So here we have used the second definition. Let's see 1, 2, 3 more examples so that we understand how to use the other definition. Let's see one more. F of x is equals to x plus 2 when my x is greater than or equals to 1. And it is x minus 2 when my x is less than 1. So again I have to find out if the function is continuous or not. So this time if you see less than 1 and greater than 1 is given, hence left hand side limit and right hand side limit will come into play. Therefore, first I'll find out left hand side limit, which can be written as limit of x tends to 1 plus f of x. So when I write 1 plus f of x, it doesn't mean you have to add, it means greater than 1. So when my x is greater than 1, so it is the function, this is my f of x. So I'll write this as f of x. So I'll get limit of x tends to 1, x plus 2. There is no denominator. We don't have to worry about indeterminate form or infinity coming. Hence, we'll directly apply the limit. So that will give me 1 plus 2, which is nothing but 3. Let's find out left hand side limit of x tends to 1 minus f of x. It doesn't mean negative, 1 minus only means that less than 1. Okay, so I will write it as limit of x tends to 1. So what is my f of x when x is less than 1? When x is less than 1, it is x minus 2. So here I'll write x minus 2. I'll apply the limit, I'll get 1 minus 2, which is minus 5. So we get that limit of x tends to 1 plus f of x is not equals to limit of x tends to 1 minus f of x. Hence, by the first definition, the given function f of x is discontinuous at x is equals to 1, because they told us to inquire at this point. So, at x is equals to 1, my given function f of x is discontinuous. Please take the screenshot of this. See, continuity is nothing new, because if we have done limits, we just have to put the limits and we have to solve the limits and we have to apply the principle. So we are not going to do a lot of sums and continuity right now. Okay. Okay, let's see one more. Hope everyone is taking the screenshot. Let us see one more. F of x is equals to x raised to 10 minus 1 upon x minus 1 and x squared. This is when x is less than or equals to 1, and this is when x is greater than 1. So again we have to find out if this given function is continuous or not. Since it is revolving around 1, which means we have to find out limit at x tends to 1. So again I'll write 1 plus 1 minus. So when I say 1 plus, which means greater than 1. So greater than 1 is this. So my function will be limit of x tends to 1, x squared. So when I substitute, I'll get 1 square, that is 1. When I do limit of x tends to 1 minus f of x, so that will be limit of x tends to 1, x raised to 10 minus 1 upon x minus 1. Now if I substitute the limit, I will get 1 minus 1, 0. That is 1 upon 0, that is infinity. So I will have to solve this. So I can write this as limit of x tends to 1, x raised to 10 minus 1 raised to 10 upon x minus 1. Okay, so we had this. What is formula of this? X raised to n, limit of x tends to 0, x raised to n upon minus a raised to n upon x minus a. So again, this is 1, it is going to give me 1 only. So this time I am getting both the limits are same, therefore I am getting limit of x tends to 1 plus f of x is limit of x tends to 1 minus f of x. Therefore, by the first definition, my given function f of x is continuous at x is equals to 1. Okay, take the screenshot. So now you know how to apply the definitions of continuity and find out if the function is continuous or not. Okay, done. So let's start with differentiation. So differentiation is the name of the process. Okay, name of the process is called as differentiation, and the procedure is, or the value which we get is called as derivative. So what is derivative is nothing but rate of change of one quantity with respect to other. And therefore we can show it as, so when I write dx, it means d. If you remember, I had said previously also, small delta, capital delta, and d. Small delta represents, capital delta represents finite change. Small delta represents small changes, whereas d represents very small changes, or it is also called as infinitesimal change. So when I write dx, it means infinitesimal change in x, which means very small change in x. If I write dy, it means very small change in y. Okay, and if I write something like this, dx of, so it means rate of change of. If I write dy by dx, so it means rate of change of y with respect to x. Okay, and this is what we also call it as derivative of y. So when I write dy by dx, it is also called as derivative of y, or in a broader sense, it is called as rate of change of y with respect to x. Hence, in our physics, when we write dv by dt, so v is my velocity, rate of change of velocity with respect to time. So this will be read as rate of change of velocity with respect to time. And we know by definition it is nothing but acceleration. So when you apply this mathematics in physics, you start getting the things which are around you. Okay, similarly, if I write ds by dt, where s is displacement, so again it will be read similarly, rate of change of displacement with respect to time. So we know that it gives us velocity. So in the real life situations, the derivatives is always going to give you some kind of a physical quantity, because each and everything in this universe is related to each other by some or the other means. So if there is a change in one, there will always be change in other, and this change found out by the mathematics, which we call it as derivative. Okay, so these are the physical definitions which I have said. Please take a screenshot of this. Now let's go to the mathematical definition. I hope everyone has taken the screenshot of this. When you find out dy by dx, that value is called as derivative. Okay. I hope everyone has taken the screenshot. Now let's see the mathematical definition. So mathematically, dy by dx, if my y is a function of x, then my dy by dx can be given as limit of h tends to 0, f of x plus h minus f of x upon h. This is the mathematical definition of a derivative. Okay? Why? Because I am writing dy by dx. Dy means infinitesimal change in y. Dx means infinitesimal change in x. So when I am talking about infinitesimal change, so the change is very, very small. How do you tell in mathematics that the change is very small? By using this symbol. When I am saying h tends to 0 or h tends to a or h tends to b, whatever it is, whatever value if I am putting over there. Okay, so when I am saying tends to, which means it is not that, but it is very much near to that. So how do you express in mathematics the smaller quantities? Always by using this, okay, limit symbol. Hence mathematically derivative can be given by this, okay, which is also called as first principle of derivative. So this definition is also called as first principle of derivative. So what we are going to do is we are going to do some 3-4 numericals by using first principle of derivative so that you can understand how we are deriving the formulas. After that we are not going to spend our time in deriving. We'll directly write all the formulae, we'll by heart it, and then directly we'll start with the numericals. Okay, but we should have an understanding as of how do this formulas, how does this formula came. So this formula can be derived by using the first principle. So first let's see some simple one and then we'll go for some formula. See, my f of x is 10x. Now I want to find out derivative of, okay, f of x. Now this derivative dy by dx. Now y was a function of x, hence it is also denoted by this symbol f dash of x. Many a times it is also denoted by y1. These are some different notations used for derivative. Okay, derivative of y can be represented as dy by dx. It can also be represented as f dash of x, or it can also be represented as y1. Okay, as we go ahead, we are going to see double derivative, triple derivative, nth order of derivative. So this suffix help us to understand that it is first order derivative or second order derivative or third order derivative. Means I'm taking the derivative of a function 2 times, 3 times, 4 times or 5 times. So this dash helps us understanding in that. If I'm taking derivative 2 times, then I'll write here 2 over here, I'll write f double dash and I'll write 2 over here, something like this. Okay, which we'll see later on. As of now, dy by dx can also be denoted as f dash of x, or also can be written as y. So I want to find out dy by dx or f dash of x. So by this definition, f of x plus h will be nothing but tan into x plus h. So when I substitute over here, therefore I'll get dy by dx, which is nothing but f dash of x, which is nothing but, by this definition, limit of h tends to 0, f of x plus h, that is tan into x plus h, minus f of x, that is tan x upon h. Therefore I get dy by dx is equals to tan x plus tan h minus tan x upon h. So plus tan h minus tan h gets cancelled, so I'll get tan h upon h, limit of h tends to 0. This h gets cancelled, so limit of a constant is constant. So derivative of tan x is 10. Therefore we get that derivative of this f of x is nothing but 10 in this case. Okay, let's see one more. Let us find out derivative of x square. My function is x square. I want to find out derivative of x square. So I'll write f of x plus h will be nothing but h plus h the whole square. So when I put in this, I'll get dy by dx is equals to limit of h tends to 0 f of x plus h minus f of x, that is x plus h the whole square minus x square the whole upon h. So this is going to give me dy by dx is equals to limit of h tends to 0 when I expand this to x square plus 2x into h plus h square minus x square the whole upon h. Plus x square minus x square will get cancelled, therefore I get dy by dx is equals to limit of h tends to 0 2xh plus h square upon h. I'll take h as common, so I'll get, and I'll cancel it out, and therefore I'll get limit of h tends to 0. From here and from here I'll take h common, I'll cancel out h, so what will remain here is 2x plus h. Now I'll substitute the limit, so I'll get dy by dx is equals to 2x plus 0. I am substituting the limit, and so I'll get 2x. Therefore, derivative of x square, which was my f of x, is nothing but 2x. Therefore, derivative of x square is 2x. It's very simple when we directly do by formula, and that is what we have to do. But we should know how are we deriving the formula, and that is why I am doing it. Everyone, please take the screenshot of this. Hope everyone is taking the screenshot. I am going for next. Let me take any constant. My f of x is constant a. So my f of x plus h will also be nothing but a only, because there is no x where we are going to do x plus h. My derivative by this will be limit of h tends to 0 a minus a upon h, that is 0. Hence derivative of a constant is 0. Therefore I can say that derivative of a constant is 0. So we have derived one formula which we will use again and again, that my derivative of a constant is 0. Okay, now let's see one more next. So now I am deriving one or two formulas. So one I have derived that derivative of a constant is 0. Next I am going to derive, say, I want to find out derivative of sin x. Okay, so my f of x plus h will be nothing but sin of x plus h. Wherever there is x, there I have to write x plus h. So by this definition, I will get dy by dx is equals to limit of h tends to 0 sin of x plus h minus sin of x upon h. So we have sum into product formula. So that is, this is how I remember, s minus s is equals to 2cs. So this can be written as limit of h tends to 0 to cos of a plus b by 2 into sin of a minus b by 2. So that will be x plus h plus x upon 2 into sin of x plus h minus x upon 2. the whole upon h. So I'll get limit of h tends to 0 to cos of 2x plus h the whole upon 2 into sine of x and plus x and minus x get cancelled, h upon 2 upon h. Now I can separate this limit and I can write it as limit of h tends to 0 to, I have taken outside, cos of 2x plus h the whole upon 2 into limit of h tends to 0 sine of h by 2, and this h I am writing it over here. You know that sine of x by x is 1, okay, and hence I am doing it. Therefore I will get dy by dx is equals to 2 into, let's substitute limit over here. So when I substitute limit over here, I will get cos of 2x plus 0 upon 2, because limit of h tends to 0, and this can be written as limit of h tends to 0 sine of h by 2. So I will have to do an adjustment over here, multiply and divide by 2. So here also sine of h by 2, here also sine of h by 2. So the limit will become 1. So here I will get dy by dx is equals to 2 into, so 2x plus 0 is 2x, and this 2 and 2 will get cancelled. So I will get cos x into this limit. We know sine of x by x is 1, so this limit is 1, and this is 2 in the denominator. So this 2 and this 2 get cancelled, and therefore I will get dy by dx is equals to cos x. That is, derivative of sin x is cos x. Okay, so this is how we can derive. So I'll show one more after that. I'm not going to derive anything. After that, we'll directly write the formulae, and that formulae we'll have to by heart, and then we'll start with the numericals. So this is how I can derive derivative of sine is cos and derivative of cos is minus sine. So we can derive all these things by using the first principle. So if we don't know limits, we'll not be able to apply the first principle. If we are not able to apply the first principle, we'll not be able to derive any of the formulae which we are going to use in the derivative. Okay, hence, okay, learning limits and the first principle is important. Hope everyone is taking a screenshot. Okay. Let's see one more, that is the last one. So this time I am taking f of x as x raised to n. So my f of x plus h will be x plus h raised to n. So by this definition, my derivative dy by dx will be limit of h tends to 0, x plus h the whole raised to n minus x raised to n upon h. Now we will have to solve this by binomial theorem. So by binomial theorem, x plus h the whole raised to n can be written as nc0 x raised to n plus nc1 x raised to n minus 1 into h raised to 1 plus nc2 x raised to n minus 2 into h square plus dash dash dash. So the last term will give me ncn x raised to 0 into h raised to n. So I'll get x plus h raised to n is equal to nc0 is 1. So x raised to n. nc1 is n. So that will be n into x raised to n minus 1 into h plus ncn is again 1. So that will be h raised to n. So this value I'll substitute over here, so I'll get dy by dx is equals to limit of h tends to 0, x plus h raised to n can be now written as x raised to n plus n into x raised to n minus 1 into h plus dash 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 h raised to n minus this x raised to n upon h. So plus x raised to n minus x raised to n gets cancelled, and here everywhere the h is going to be there. So I can take h as common, so I'll get limit of h tends to 0. When I take h common, I'll get here as n into x raised to n minus 1 plus h into x raised to n minus 2 plus dash dash dash, and here I'll get h raised to n minus 1. The whole upon h. So this h and this h will get cancelled. Now there is no 0 in the denominator, so we can apply the limit. So I'll get dy by dx is equals to, I'll substitute the limit to n into x raised to n minus 1 plus 0 into x raised to n minus 2 plus dash 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 plus 0 raised to n minus 1. 0 raised to anything is 0 only, 0 into anything is 0 only. So finally I get dy by dx is equal to, only this term remains, that is n into x raised to n minus 1. So this is how I can find out the derivative of this. The derivative of x raised to n is n into x raised to n minus 1. So this is how I have used the first formula, first principle, and I have derived certain formulae. Take the screenshot of this. After this I am going to write the formulae, and all this formulae you have to take a screenshot by heart, and then we'll start the numericals. Hope everyone has taken the screenshot. So this is how we can derive the formula which we are directly going to use. Okay. So now I am going to write the formula. Please note it down and take the screenshot. And then we'll start with the numerical. First is derivative of x raised to n is n into x raised to n minus 1. Derivative of root x is 1 upon 2 root x. Derivative of a constant is 0. Derivative of e raised to x is e raised to x. Derivative of a raised to x is a raised to x into log of a. Derivative of log x is 1 by x. All this can be derived using the first principle, but we are not going to waste time in that. Then derivative of sin x is cos x. This is what we have already derived. Then derivative of cos x is minus sin x. Then derivative of tan x is x square x. Derivative of cot x is minus cos x square x. Derivative of sec x is sec x into tan x. derivative of cosec x is minus cosec x into cot x. Then derivative of sin inverse of x, 1 upon under root of 1 minus x square. Then derivative of cos inverse of x, minus 1 upon under root of 1 minus x square. It is the same for all the inverse trigonometric ratios, only sign will be different. Next, derivative of tan inverse of x is 1 upon 1 plus x square. Derivative of cot inverse of x is minus 1 upon 1 plus x square. Then derivative of sec inverse of x is 1 upon x into under root of x square minus 1. And derivative of cosec inverse of x is minus 1 upon x into under root of x square minus 1. Take the screenshot of this, start by adding and giving you 2 minutes. Because I'm not going to, when I do integration, I'm not going to give you separate formulae for integration. We'll by heart the formula of derivative, and on the basis of derivative only we are going to study integration. We'll not learn new formulae in integration. Instead, we'll remember it in terms of derivative. Hence, everyone, I'm giving you 2 minutes. Okay, take this screenshot and start by hearting. I hope everyone is trying to by heart it. Let's start with some numericals. So everything in this chapter is on the basis of this formula only. If you don't remember the formula, you will not be even able to pick up your pen in the exam. Or you will not be able to even write one line of this, okay, numerical of derivative. Hence, by hearting the formula is very important. Because everything is on the basis of formula only. Let's see some rules also. One we call it as u plus minus v rule. It says that if I want to take derivative of two different functions, u and v are functions of x, okay, and I am taking derivative with respect to x of two different functions u and v, and these two functions, if they are in addition or subtraction, then I can give this operator d by dx. This is also called as differential. If I simply write dy, if I simply write dx, if I simply write dz, these are called as differentials. So I can do like of a bracket multiplication. How we do a bracket multiplication? In similar fashion, I can do like this, and I can write it as d dx of u plus minus d dx of v. That is du by dx plus minus dv by dx. Second is, if the two functions are in multiplication, both u and v are function of x, okay, and they are in multiplication. So then keep one function constant, take derivative of other, then keep the second one constant and take the derivative of first. So u dv by dx plus v du by dx. So instead of by hearting, you just remember the procedure. What we are doing is we are keeping one constant, we are taking derivative of the other. Then we are putting a plus sign, and then we are keeping second this time constant, and we are taking derivative of the first. Next, if two functions, okay, are in division, here the functions were in addition or subtraction, here the functions were in multiplication, here the functions are in division. So that time, okay, many times for need used to always be a confusion, and that is why I remember it in this fashion. The upper one I call as high and the below one I call as low. If you remember, you must be have already done in physics, and your first, very first lecture in the physics was also about basic mathematics only. And there in integration, you must have seen a principle: upper limit minus lower limit. Okay, when the limits are there and when you are doing integration, if you remember, in many physics, the derivations also you must have done. You always do upper limit minus lower limit. So it will help you to remember. High means upper limit minus lower limit. Okay. So first I'll take derivative of this. Then I'll take derivative of lower. Okay, so it will be v du by dx minus u dv by dx, the whole upon u square. Similar to this, but here there was a plus sign, here we have minus sign, and we are dividing it by v square. So these are called certain rules of derivative. We call them as rules of derivative. Apart from there is one more rule, which we call it as chain rule. But first, let's just try to apply these rules, and then we'll go for the chain rule. So I have, say, y is equals to x square plus 3x minus sin x. Now I want to find out derivative of this with respect to x. So I'll write d dx of y is equal to d dx of x square plus 3x minus sin x. In mathematics, we cannot bring anything from air. So if I am multiplying by differential here, then here also I'll have to do the same thing. So this is how we get derivative. So I'll get dy by dx, that is derivative of y is equals to. So like how I just showed you, we can separate this differential sign. So that is what I'm going to do. d dx of x square plus d dx of 3x minus d dx of sin x. Therefore, I'll get dy by dx is equals to derivative of x square. So formula, it falls into the formula x raised to n. So derivative of x raised to n is n into x raised to n minus 1. So this will become 2 into x raised to 2 minus 1 plus constant will always come out with derivative limits integration. So this will become 3 into d dx of x minus derivative of sin x, we know it as cos x. So I'll get therefore dy by dx is equals to 2 into x raised to 2 minus 1, that is x raised to 1, so that can be written as just 2x plus this dx gets cancelled, so I'll get 1 3 into 1 is 3, so 2x plus 3 minus cos x. So y was given as x square plus 3x minus sin x, and derivative of that is 2x plus 3 minus cos x. Keep taking the screenshots. Taken the screenshot. Let's see next. Y is equals to e raised to x into sin x. Now if you see, this is a different function, this is a different function. So it falls into the second category, u into v, where two different functions are in multiplication. Therefore, by this formula, I get dy by dx is equal to, keep e raised to x is constant, take derivative of sin x, then keep sin x as constant, and take derivative of e raised to x. Therefore, I'll get dy by dx is equals to e raised to x derivative of sin x is cos x plus sin x derivative of e raised to x is e raised to x only. E raised to x I take common, so I get cos x plus sin x. Therefore, derivative of e raised to x sin x is nothing but e raised to x into cos x plus sin x. Okay, let's see one more. Y is equals to e raised to x upon x square. So this time two functions are in division. So I will apply this formula, which is also called as u by v rule. So dy by dx will be, okay, first I'll take derivative of upper one, so x square into d dx of e raised to x minus e raised to x into d dx of x square, the whole upon, sorry, there was x square, the whole square. Okay, I'll get dy by dx is equals to x square, e raised to x derivative is e raised to x minus e raised to x derivative of x square will be 2x, and this will become x raised to 4. So I can take x into e raised to x as common, therefore I get dy by dx is equals to x into e raised to x I have taken common, so here what will remain is x, and here what will remain is 2 upon x raised to 4. So 1x gets cancelled, so I get dy by dx is equals to e raised to x into x minus 2 upon x cubed. So this is the value of my derivative. Okay, take this screenshot. In your school, you must have done this in greater depth. So I'm just giving you a kind of a quick revision kind of a thing, so that I can go to the higher level problems. Okay, everyone has taken the screenshot. Now let's explain. Let me explain one more chain rule. Then we'll start with the numericals. Now apply a chain rule in a different manner. So if you already know, you just see if you are able to understand by my method, it's good. If you are not understanding by my method, then don't confuse yourself. Whatever method you know properly, you can go by that method. So first is, when do we apply a chain rule? When it is a composite function. What is the composite function? Function of a function. So for example, I have y is equals to log of sine of x. See, it is not log x into sine x. If it is log x into sine x, then u into v root. But it is log, instead of x, I have sine x. So it is log sine of x. So it is function of a function. Suppose I write square root of sine of x square plus 3. So now square root is one function, sine is another function, x square plus 3 is another function. So this also falls into the category of composite function, that is a function of a function. If I write like this, then this is also a composite function only, because trigonometry we have sine, okay, cos, cot, tan, cot and cosec. When I'm writing like this, I'm giving the powers, and the powers we give in algebra. Again, this is also considered as a composite function. Why? Because it can be written something like this. Sine of x the whole raised to 4. So let's see how to apply the chain rule. So how I do is, I don't remember the rule like that. Instead, I do with the procedure. After is equal to sign, I see log, and then I see sine. So I will write 1 and 2, indicating that first I'll take derivative of log, and then I'll take derivative of sine, and I'll multiply both. So I'll get dy by dx is equals to derivative of log x is 1 by x, so that will be 1 upon sine x into derivative of sine x. Okay, so first I took derivative of log, and now I am taking derivative of sine x. So it will give me dy by dx is equals to 1 by sine x into derivative of sine x is cos x. So cos x by sine x is going to give me cot x. Okay. Similarly here, when I come over here, after is equals to, first what I see is square root. So I'll give 1 to square root. Then the moment I enter into the square root, I see sine function. So I give number 2 to that. After that, it should have been x. Now instead of x, there is x square plus 3. Hence I'll give it as number 3. So when I write like this, what I do is, I'm giving the order that first I'm going to take derivative of square root, then I'm going to take derivative of sine, and then I'm going to take derivative of x plus 3. So therefore, dy by dx. What is derivative of square root of x? 1 upon 2 root x. So that will be 1 upon 2 root sine of x square plus 3 into d dx of, next I'm going to take derivative of sine, so into d dx of sine of x square plus 3 into d dx of, now third derivative I'm going to take of this. So this is how I do the chain rule. Okay, I write 1, 2 and 3 so that I can explain my mind that first I have to take derivative of this, and then this. So this is what the same order I have written. Okay, so I'll get dy by dx is equals to 1 upon 2 root sine of x square plus 3. Derivative of sine is cos, so this will be cos of x square plus 3. Then derivative of x square will be 2x, and derivative of 3 will be 0. So this 2 and this 2 gets cancelled, so I'll get dy by dx is equals to x into cos of x square plus 3 upon root of sine of x square plus 3. Okay, so this is the derivative of the second function which I have written over there. Please take the screenshot. Please take the screenshot. Okay. Hope everyone is taking the screenshot. Now, whichever method you find out easy, you can go for that. Now, I'm doing the next one. So, I'll explain my hat. This is why I've written something like this. So, first I'll take derivative of this, and then I'll take derivative of this. So, derivative of x raised to n is n into x raised to n minus 1. So, that will be 4 into sine of x raised to 4 minus 1 into, next I'm going to take derivative of sine x. So I'll get dy by dx is equals to 4 sine x the whole cube into derivative of sine x is cos x. So I'll get dy by dx is equals to 4 sine cube x into cos x. So this is my derivative of this. Now you guys can try this next one. Try this in your book. Y is equals to log of square root of 1 minus cos of 3x by 2 upon 1 plus cos of 3x by 2. I have to find out derivative of this. What will be the value of dy by dx? Everyone try this. I'm giving you 1 or 2 minutes. Try this if you are able to solve. Hope you guys have tried it. Okay, now if we directly blindly apply chain rule everywhere, then also it will be a problem. As in this case, if I directly blindly apply chain rule, I'll be in a very big problem. Because if I go, then first I see log, so I will have to take derivative of this. Then I will have to take derivative of this. And then I will have to take derivative of this. Derivative of log is 1 upon something, so then I'll get 1 upon this entire big term. Then derivative of this is square root is 1 upon 2 root, so again I'll get one more this big term. Then derivative of this, so again this will be u by v, again I'll get a very complex and big term. So here, if I directly blindly apply chain rule, I'll be in a trouble. Okay, and that is why I said you try a little bit, you'll understand. Don't directly apply the chain rule always. Here it is possible to simplify it, then only we'll apply it. So let's try to simplify it. So y is equals to log of Now you must have studied cos 2x is equals to 2 cos square x minus 1, and cos 2x can also be written as 1 minus 2 times sin square x. From there only these two formulas have come. 1 plus cos 2 theta is 2 times cos square theta, whereas 1 minus cos 2 theta is 2 times sin square theta. Remember this formula, it's very important in entire derivative and integration. Time and again we are going to use this formula. So 1 plus cos 2 theta can be written as 2 times cos square theta. Here it is 2 theta, so it is becoming half of that. So here also I can apply the similar one. So 1 minus cos 3x can be written as 2 times sine square. If it is 2 theta, it becomes half. So half of 3x by 2 will be 3x by 4. So this will be 3x by 4 upon 1 plus cos 2 theta is 2 times cos square theta. So this will become 2 times cos square. Half of 3x plus 2 will be 3x by 4. These two get cancelled. Then here I have square and here also I have square. So square and square root will get cancelled. So I'll get y is equals to log of sine 3x by 4 upon cos of 3x by 4. So sine by cos is tan. So I'll get y is equals to log of tan of 3x by 4. So now this problem, has got converted into a much smaller and easier problem. Now I can apply chain rule. So first I'll take derivative of log, then I will have to take derivative of tan, and then I will have to take derivative of 3x by 4. So now I'll get dy by dx is equals to derivative of log is 1 upon x, so that will be 1 upon tan of 3x by 4. Then derivative of tan is sec square, so that will be sec square 3x by 4. Then I have to take derivative of 3x by 4, so derivative of 3x by 4 will be only 3 by 4. 3 by 4 will come outside derivative, and derivative of x is 1. So this will be my final answer. If you want to further simplify, you can simplify it, or you want to leave it over here, you can leave it over here. So derivative of y is equal to log of root of 1 minus cos 3x upon 1 plus cos 3x by 2 is this. 3 into sec square 3x by 4 upon 4 into tan of 3x by 4. It's clear? So this numerical was only pointed out, to prove that every time blindly we cannot apply Let's see the next numerical now. So what I'm going to do is I'm going to write some numericals on the right hand side so I don't have to again and again see my notebook. Cos inverse of 4 cos cube x minus 3 cos x, then tan inverse of 1 minus cos 3x upon sin 3x, then third cos inverse of 1 minus 9x square upon 1 plus 9x square, then tan inverse of 2 into e raised to x upon 1 minus e raised to 2x. Then fifth, tan inverse of root of 3 minus x upon 3 plus x. So I have written certain problems, so we can start solving this one by one. So let me take the first one. Y is equals to cos inverse of 4 cos cube x minus 3 cos of x. Now again, if I directly apply the chain rule, I will be in a very big problem. Because derivative of cos inverse of x is minus 1 upon under root of 1 minus x square. So if I directly apply the chain rule, then I will get minus 1 upon under root of 1 minus this entire term. Okay, and then simplifying this entire term will become very complex. So we'll try to remember, or we'll apply some formula and then only we'll apply. So if we remember, cos 3 theta formula is 4 cos 3 theta minus 3 cos theta. It is exactly same. So I can write y is equals to cos inverse of, instead of entire this I can write it as cos 3x. So now we know that cos inverse and cos are going to cancel each other. So I'll get y is equals to 3x. So now see, it became very simple. Cos and cos inverse, they have cancelled out each other, and now taking derivative will be very easy. So my dy by dx will be 3 will go outside, d dx of x, the derivative of x is 1, so we'll get dy by dx is equals to 3. So therefore derivative of y is equals to cos inverse of 4 cos cube x minus 3 cos x is nothing but very simple. That is dy by dx is equals to 3. Okay, take the screenshot. Let's try next one. Y is equals to tan inverse of 1 minus cos 3x upon sin 3x. So 1 minus cos 2 theta is 2 times sin square. So this will become 2 times sin square, half of this, so that will become 3x by 2. Similarly, we know sin 2x is 2 times sin x into cos x. Therefore, this can also be written as 2 times sin x. So, half of 3x by 2 into cos of 3x by 2. So, now this 2 gets cancelled. One sin and one sin gets cancelled. So, sin by cos is tan. So, I'll get y is equal to tan inverse of tan of 3x by 2. So now tan and tan inverse will get cancelled, and I'll get y is equal to 3x by 2. Therefore now derivative will be 3 by 2. Derivative of x is 1. You see, it became simple. So every time we are not going to blindly apply the chain rule. Okay, many times we'll think and then only we are going to apply the chain rule. Okay, please take the screenshot of this. Okay, I hope everyone has taken the screenshot. I'll rub. Now next one, we have to think a little bit here also, because directly applying the chain rule will create a lot of problems. So I have this third one, cos inverse of y is equal to cos inverse of 1 minus 9x square upon 1 plus 9x square. Again, if I directly apply derivative, I will be in a very big problem. Okay. So again, we have to think something over here. We can write y is equals to cos inverse of 1 minus 3x the whole square upon 1 plus 3x the whole square. Okay. Now we are going to see one more thing which we call it as substitution over here. So if we remember, now we have whenever we have the something like cos inverse, we can always think about cos inverse gets cancelled or tan inverse gets cancelled. Now previously also two numericals we had done. So from the same point of view, so here also we have to think, can I get cos over there? So yes, we have one more formula. Cos 2x can be written as 1 minus tan square x upon 1 plus tan square x. This is 2x and here I have half angle of x. Okay, and if you see here, this is similar one. So I can substitute. Okay, let 3x is equals to tan of x. So if I do like that, so this will become y is equals to cos inverse of 1 minus. So instead of 3x, I am writing tan x and it is square, so that will become tan square x upon 1 plus tan square x. So I'll get y is equals to cos inverse of, and this we know it is nothing but cos 2x. So this entire thing is going to give me cos 2x. So now cos inverse and cos got cancelled and only what remains is 2. So now derivative became much more simpler and the derivative of this 2x will be 2. Hence the derivative of cos inverse of 1 minus sin square x upon 1 plus sin square x is nothing but 2. So ones which used to look very complex one can just be used trigonometric formulas and be made easy. Okay, hope everyone is taking the screenshot. Please every time keep taking on the screenshot. Now let's try next one. Fourth, tan inverse of 2 e raised to x upon 1 minus e raised to 2x. Okay, so again whenever we are getting this, we have to think in that mode. And what is that? I should get tan so that tan and tan inverse get cancelled, or I should get at least cot, and cot can be written as 1 upon. Why do you require break? Now we have only half an hour left. I also require break, but I'm continuing because only half an hour is left. Students, please, half an hour is only left now. I also wanted break because I am also exhausted. I'm taking class since 9 o'clock in the morning. If it was not okay nearing to 5, I would have given the break because I myself require break. But since half an hour is left, we'll continue. Okay, if you want, we can stop early, maybe say 5-10 minutes. But please let us continue. So we'll think in the terms of somehow to get tan over there. So we have one more formula. If we just remember, tan 2x can be written as 2 times tan x upon 1 minus tan square x. This 2x becomes half. This is also half angle formula. So if you see the similar term is there, now only instead of tan x, we have e raised to x. So what we'll do? We'll do substitution, put e raised to x is equals to tan of x. So I'll get y is equals to tan inverse of 2 into tan of x upon 1 minus e raised to 2x. So e raised to 2x is nothing but e raised to x the whole square. Hence it can be written as 1 minus tan square x. So I'll get y is equals to tan inverse of this becomes tan 2x. So now tan and tan inverse will get cancelled. Therefore I'll get y is equals to tan inverse got cancelled and I'll get 2x and derivative of 2x will be 2. Okay, you can just take a break of 2 minutes or 5 minutes if you want. But don't go, I'll be here only. Just take a break of very small 2 to 5 minutes. Everyone is there. So our short break is done. I was also not going to take the break. Okay, but I've just received one thing. I just sharing my screen. Are you guys able to see the screen? Okay, so yes, I have been named in the list of top 100 teachers. Okay, and that is why I just took a break. You can see my name over here. I've shared the screen. So the teachers who guided numerous students. So top 100 list is there. In the first list we have professors. In the second list we have researchers. In the third place we have teachers. So you can see my name over here as E.R. Hemant Mehta. Okay, and that is why I just taken a break of that small 5 minutes. So I have been named in Fox Clues as well as Indian Saga. Okay, as well as in Hindustan Times also it is going to come. And that is why we had just taken a small minute of break. So I felt like I should share with the class which is ongoing and hence. Okay, so let's start once again. Let's see some more numericals. You are able to see the board? Are you able to see the board? Okay, now are you able to see the board? Now, yes, I guess now the board is clear. Okay, let's try some more numericals. So I have here y is equals to x raised to a plus x raised to x plus a raised to x. Now how we are going to take derivative of this? See, now we have derivative of this. This is like x raised to n type. This is a raised to x. We have direct derivative of this also. But how are we going to take derivative of this? Because if we just see the formula, we don't have any direct formula for x raised to x. It is variable raised to variable. We have this variable raised to constant, so that is x raised to n type. We have constant raised to variable, that is a raised to x. But how are we going to take derivative of this x raised to x? Okay, and that is the time when we call logarithm to our help. Okay, why? Because we know that log of x raised to m can be written as m into log of x. So if we take log, it is going to help us, and that is why I will call log. But don't do this mistake of taking log directly. If I do like this, then I'll get log of x raised to a plus x raised to x plus a raised to x. Again, I cannot do anything of this because whatever properties we have, log of m into n can be written as log of m plus log of n. Log of m plus n cannot be written like this. This will remain as it is. You cannot do anything of this. So don't do a mistake directly taking log. So instead what I'm going to do over here is, okay, I can take, let x raised to a is equals to u, x raised to x is equals to v, and a raised to x is equals to w. Therefore, my y will become u plus v plus w. Okay, it will become u plus v plus w, and now I will take derivative because I have to take derivative with respect to x. It is asked in the question. So I will have to take with respect to x only. So I will write dy by dx is equals to d dx of u plus v plus w. So we have already seen this rule. So I can write it as du by dx plus dv by dx plus dw by dx. Okay, so I want to find out basically the value of dy by dx. So dy by dx, this is how it can be written as du by dx plus dv by dx plus dw by dx. So I will find out. So my u is x raised to a. Directly I can take derivative without worrying derivative. So du by dx will be nothing but a into x raised to a minus 1. Because the formula of x raised to n is n into x raised to n minus 1. Then we have b as x raised to x. Now we don't have direct formula for this. Hence what I'm going to do over here is I'm going to take log. I'll take log on both sides. So I'll get log of v is equal to log of x raised to x. So by this property, this power will come down and it can be written as x into log x. Now I can take derivative. So now when I take derivative, I have to take derivative here also. Derivative of log will be 1 by v dv by dx is equals to. Now here we'll apply u into v rule. X derivative of log x is 1 by x plus, now I'll keep log x constant and derivative of x will be 1. So I'll get 1 upon v dv by dx is equals to this x gets cancelled. So 1 plus log x into 1, that will be log x. This v I will take over here. Therefore, I'll get dv by dx is equals to v into 1 plus log of x. And what is the value of v? X raised to x. So I can write dv by dx is equals to x raised to x into 1 plus log of x. Okay, so I got the value of dv by dx also. I've got the value of by dx also. Now w is a raised to x. We directly have formula for this. dw by dx is a raised to x into log of a. We have direct formula. So I'll substitute these values in equation number 1. Then I'll get the value of dy by dx as du by dx is a into x raised to a minus 1 plus value of dv by dx is x raised to x into 1 plus log of x, and dw by dx is nothing but a raised to x into log x. So I've got the derivative of this, what he has asked us. It asked us what is the derivative of x raised to a plus x raised to x plus a raised to x. So I've got this. Okay, the value is a into x raised to a minus 1 plus x raised to x into 1 plus log x plus a raised to x into log of x. Please take the screenshot of this. Please take the screenshot of this. Okay, I hope everyone has taken the screenshot. Let's do next one. So sin x raised to tan of x, sin x raised to tan of x minus x raised to log x. So again we know that we don't have any formula for variable. Sin x is also variable, tan x is also variable. So we have no other choice other than taking log. So but directly we cannot apply the log. So like last time, let u is equals to sin x raised to tan x and let v is equals to x raised to log x. So the given numerical can now be written as y is equals to u minus v. So now my dy by dx will be du by dx minus dv by dx. So like last time, we'll find out the value of this. So my u is sin x raised to tan of x. So I directly cannot take derivatives, so I will take log. So log of u is equals to log of sin x raised to tan x. So power will come down, so it can be written as tan x into log sin of x, log of u. So now when I take derivative of log will be 1 by u into du by dx is equals to, now here I will have to apply u into v. So I'll keep tan x as constant and I will take derivative of log sin x. So here I will have to apply chain rule. Derivative of log is 1 by x, so that will be 1 by sin into derivative of sin will be cos x, plus I'll keep log sin x as constant and I'll take derivative of tan x, that will be sec square x. Therefore I'll get 1 by u du by dx is equals to cos by sin is cot, so tan x into cot x plus sec square x into log sin of x. Now cot of x can be written as 1 by tan x, and therefore tan and cot they will cancel out each other and what will remain is 1. So I will get 1 by u du by dx is equals to 1 plus sec square x log of sin x. This u will go over here, therefore I will get du by dx is equals to u into 1 plus sec square x into log sin of x. So value of u is sin x raised to tan x. So I will get du by dx is equals to sin x raised to tan x into 1 plus sec square x into log of sin of x. So this is the value of du by dx. Now I will have to find out value of dv by dx. So my v is x log x. So I will take log. So I will get log of v is equal to log will come down. So log x into x. So 1 by v dv by dx is equals to, here I will apply u into v. So log constant and derivative of x will be 1. Then x constant and derivative of log x will be 1 by x. So I'll get 1 by v dv by dx is equals to log of x plus 1, x gets cancelled 1. V I will take over here. So I will get v into log of x plus 1 and therefore I will get dv by dx is equals to, what is value of v? X raised to log x. So it will be x raised to log x into 1 plus log x. So that's equation number 2. Equation number 3. When I put into 1, I will get the value of dy by dx. So put 3 and 2 into 1. And I will get dy by dx is equals to, this is sin of x raised to tan of x into 1 plus sec square x into log sin of x minus dv by dx, that is x raised to log x into 1 plus log x. So this is the answer of derivative. So I have been given y is equals to sin x raised to tan x minus x log of x, and derivative of this is this. This we call it as logarithmic differentiation. So whenever we are faced with a problem of, okay, like this, variable raised to variable, that is the time when we can recall this log and we can solve our problems. Done. Please take the screenshot. Take the screenshot of this. Just a minute. Let's see next problem. This is the one where we can do logarithmic differentiation. Let us see one more situation where we can go for log. It's not that we can use only when it is variable raised to variable. Wherever we see a lot of complexity with powers and all, that is also the time when we can go for logarithmic differentiation. Let's see this question. I've been given as y is equals to e raised to x square into tan of x raised to 3 by 2 upon 1 plus x square raised to 3 by 2 into cos cube x. Now if I directly try to take derivative over here, okay, my entire GWE paper time will get over, but I'll not be able to solve this. Okay, I'll not be able to solve this. So what we can do over here is, again I can go for logarithm. I can again go for logarithm because we know log of m by n is log of m minus log of n. So again I can take log over here directly. So log of y will give me log of e raised to x square into tan of x raised to 3 by 2 upon 1 plus x square raised to 3 by 2 into cos cube x. So I'll get log of y is equal to log of m minus n can be written as m upon n can be written as log m minus log n. So this will become log of e raised to x square tan of x raised to 3 by 2 minus log of 1 plus x square the whole raised to 3 by 2 into cos cube x. Furthermore, we know that log of m into n can be written as log of m plus log of n. Hence, I can write log of y is equal to log of m plus log of n. So that will become log of e raised to x square plus log of tan of x raised to 3 by 2. Similarly, here, this log of m into n can be written as log of m plus log of n. So that will be log of 1 plus x square raised to 3 by 2 plus log of cos cube x. So it can again be written as log of y is equal to, this is power will come down. So that will become 2 log of e raised to x, or instead this is log and anti-log. Log and anti-log will cancel each other. So I'll be left with x square plus, this is the power, this will come down. So 3 by 2 log of tan of x minus, this is the power, 3 by 2 will come down, log of 1 plus x square, minus plus minus, this cos cube can be written as cos x the whole cube. So this power will also come minus 3 log of cos x. Now it has become very simple, which once used to look very, very complex, now has become simple, and we can now take derivative. So I'll get 1 by y dy by dx is equal to derivative of x square is 2x plus 3 by 2. Here chain rule, derivative of log is 1 by x, so 1 by tan x, and derivative of tan x is x square x minus 3 by 2. The derivative of log is 1 by x, so this will become 1 upon x square into derivative of 1 is 0, and derivative of x square is 2x minus 3 log of 1, x is log of derivative of log x is 1 by x, so this will become 1 by cos x, and derivative of cos x is minus sin x. So I'll get 1 by y dy by dx is equal to 2x plus 3 by 2 x square x upon tan x, which can further be simplified, minus 3 by 2 into 2x, so that will give me 6x upon 2 into 1 plus x square, minus minus will become plus, 3 sin x by cos x will become tan x. And this y you can take it over here, so that final answer will get as dy by dx is equal to y into 2x plus 3 x square x upon 2 tan of x minus 2 1s are 2 3s are, right, that will become 3x upon 1 plus x square plus 3 tan of x. So let it be y only over there, because this y term is very big, so writing this y again over here will make look very, very, very big, and therefore I am avoiding writing, and I am just writing it as y only. So I hope you have understood when and how to use logarithm. It's not that only when it is variable raised to variable. By this numerical I have showed you, even if it is not variable raised to variable, if it is such complex kind of thing, okay, by logarithm it can be made very easy. Okay, take the screenshot. Everyone take the screenshot. Taken. Okay, then today's lecture get over here. In the next class when we come, we will see implicit function, and then we can directly go with some JEE and AIEEE numericals. Okay, have a nice day ahead.